Welcome dear viewers and students. In this sessions we have to see about projection of straight lines part 2. Already I discussed what about straight lines, so what type of and what do you mean by traces and so on in previous session, but in that session I just solved only 2 problems. The remaining 3 problems, but there are a lot of problems are there, but for discussion and for clarification we are taken only limited problems. So in that in this session I have to see about the remaining 3 problems, so what I said in the previous. But now in part 1 already we have covered number 1 and 2, that is how we are going to find out true length and how to determine the inclinations. So true length to be determined by 2 ways, one is rotating line methods and another one trapezoidal methods. So and also I clearly defined so how the rotating line methods works and what about trapezium methods. So in what sense you have to determine the inclination with respect to horizontal plane and vertical plane. But now we are looking about the remaining problems, that is under part 2. In this question number 3, that is problem number 3, the plan, look at the problems, look at these problems. The plan and the elevation lengths of a line AB 70 mm long or 60 mm and 50 mm. I just move in right side, that is better for your clarifications. Here the plan and elevation length of a line AB 70 mm long or 60 mm and 50 mm respectively. So end A is 10 mm above HP and 15 mm in front of VP. Draw the projection and determine the inclinations with HP and VP. So how to start these problems? Already I stated, whenever we are come in projection, we just started. First we are given number of problems, then take rulers, that is scale. So in this I just draw a XY line, that is reference line. So reference line, draw a reference line, that is XY. So whatever it is, okay. Then whenever we are followed except perspective, that is pictorial projection, the remaining projection must follow the reference lines, that is intersection of planes HP and vertical plane. So this is how to start. So what is our problem in this? Plan and elevation, a length of line AB 70 mm long. So a line is 70 mm. So the plan distance, so when you look from top, a straight line having 70 mm, if you look, so what about the distance apparent length 60 mm, that is plan vision. The same thing if you look in front of, so that length of line 70 mm visioned as 50 mm in front of, so that is given here. But where to start? Already I said, if you want to construct any straight line, we are need 2 endpoints. So the endpoints are lies in a projectors. So here we have to construct a projectors, draw a line, that is imaginary or reference to the views, that is end A is 10 mm above HP, 10 mm above HP, 15 mm in front of VP. So above HP means above XY line 10 mm. So if it is the HP A dash, so we have to here we have to take vertical scale, that is perpendicular, because here I followed a package, that is open board, but I am not using any other peculiar instruments. So here it is not available mini drafter. So instead of mini drafter, 2 rulers I applied, one ruler for horizontal, another ruler for vertical, that is perpendicular. So, by using this perpendicular ruler, I just mark 10 mm. So, that is given in this problem 10 mm end A. Yeah, try to look at here, I just place it in red color for variation thickness here. End A 10 mm above HP. Above HP means it is looking, these views appear by looking in front of, that is A dash, because capital A represent the true point. So, what about the views? So, elevation represent A dash, plan represent without dash, small a, small letters. So, A dash, so 10 mm above. So, here for 10 mm we have to mark a point. So, 10 mm. So, we have to mark 10 mm, 10 mm above xy, that is A dash, that one is A dash. So, I just mark away from here A dash, A dash. So, what about the other parameters? Other parameters here. So, try to look at this 15 mm in front of VP, 15 mm, 15 mm in front of VP. So, what do you mean by in front of? So, already I said in front of. So, in front of vertical plane, if you are looking above, that is top, that traces on horizontal plane, while you rotate clockwise it comes below xy line. So, 15 mm below xy. So, here in the same projectors 15 mm. So, we have to mark 15 mm. I just change over these points because black color is it? $15 mm. But what to do? Yeah, we have to construct a projectors. Yeah, first after finding A dash, so immediately we have to construct a projectors, then only we have marked. So, construct a projectors. Construct a projectors. Construct a projectors. Yeah, below 15 mm in front of VP. So, in that 15 mm in front of VP, we just go for small a, because it represents plan, elevation represents A dash, plan represents small letters A. So, this is given here, is it? So, first we are mark it to 1 endpoints. So, with respect to vertical plane and horizontal plane here. So, what about the length, a plan and elevation length of line AB 70 mm. The true length is 70 mm long, AB, capital A, capital B. So, long or 60 mm. So, 60 mm means while look from above, the true object of 70 mm long, look from top, it look like say 60 mm. So, 60 mm. So, here we have to mark 60 mm. So, by using the scales 60 mm, we have to mark 60 mm. Okay. We have to mark 60 mm. By using perpendicular scales, that is in mini drafter, please go through the mini drafter usage. In that mini drafter, there are two scales, one is horizontal scale, another one perpendicular to that. But you have to make any inclination also, that is a angular plates in scale end. So, by use of that you have to access multiple applications. So, without go for any separate rulers, that is the application of mini drafter. So, with the help of mini drafter perpendicular scales, so we have to draw a projector. So, why I drawn this? Because the plan view of the two objects 70 mm long. So, while look from above, so that should be in below, is it? So by marking 60 mm, okay, above and below I have to draw a line, draw a projectors, and also I just draw for dimension. Okay, I have to mark dimensions. So what about this dimension is it? So for marking dimension also we are using this. Simply we are mark the dimensions, at present not, at the end of. So now we are going to construct dimensions. 60 mm is it? So 60 mm we have to construct a dimensions. mm. So we have to construct a dimensions. So here 60 mm. So that we have to mark the distance between this endpoint and another endpoint, because plan, while you look from top, the actual 70 mm AB looks as 60 mm. So what about the true object? That should be in above, that is from A dash, but you have to keep A dash as true point. So here both, so I just keep that A dash as elevation as well as true point. So capital A also represent here, so I just make it above, capital A, but I am not show it comma, capital A also there. But what about the true length? 70 mm. So now we have to take campus. So in this campus we just said 70 mm. 7 centimeter is it? 7 centimeter. So take campus, that is engineering campus. So measure 70 mm in ruler. You just place it here, because measure 70 mm by using this ruler, 70 mm. Try to look at this. Yeah, 70 mm. After measuring 70 mm in campus, so put this needle, that is this needle on A dash needle, and make an arc. I just erase the portions. Yeah, this is not needed, no? That's why I just erased. So make an arc. Yeah, this measurement shows the true length of capital A, capital B. While you look from top, that plan should be give 60 mm. That's why the other projector you have to draw for at a distance of 60 mm, and in that projector you have to make an arc to cuts at a radius of 70 mm, that is true length. So that is the concept. So I think I just place it away, that compass. Now take another scale. So placing over this point, and draw a line. Yeah, for this, yeah, another scale, because I am never to disturb these scales. So because I need perpendicular and horizontal, I never to disturb this. So one more scales I have needed. One more scale I am needed. So perpendicular to this, that's why. For marking dimensions, for that purpose I am using this. So that's why I am telling to go for mini drafter, because mini drafter in this position. So I just take it and draw a extension line away from here, extension line. draw extension line, then shift into this, draw extension line. I move away from here and place it somewhere, and move the scales to here and draw a dimension line, and move away from here and erase the extended portions, unwanted is it, and erase extended portions. So then I mark it error gates. So error gates is very, very important. So try to, because here it's very difficult to construct, so that's why I am not clear, is it? So draw error gates. So after completion, this is capital A, capital B at a length of 70 mm. 70. So similar in similar. So this is to construct elevation, is it? So while you look the elevation, that plan view gives 60 mm, but in similar case in opposite. So what it looks? Yeah, if you look elevation, so how much distance is given? That is in these problems. Yeah, elevation looks 50 mm. That 50 mm where we gets, yeah, it's in above, that comes in below, is it? While you looking from where you get it the true length. So the true length is observed, is it? The true length of elevation, that is, it is inclined to it is inclined, is it? It is inclined to HP. So that is the true length. So 50 mm. So here in below XY, in below XY, so we have to measure 50 mm. Now we have to measure 50 mm. So measure 50 mm. Measure 50 mm. Measure 50 mm. So draw a projectors. Measure 50 mm. Draw a projectors, because no need of above, is it? So already we constructed. Why we go for that? So below. So draw a projectors. So that is 50 mm, is it? But actually here this campus, I am not sure about whether it comes, yeah, 50 mm. It not comes to 50 mm, around 5.3. So we have to approximately rotate the scale and fix. Yeah, that is enough. So we have to rotate the scale from that point and fix where 50 mm intersect this. 50 mm intersect. I just rotate. But here it not possible. That's why I am telling, because 50 mm in this campus it not adopted 50 mm. So I just take the scale, by use of that scale itself 50 mm I have to mark. So how? Yeah, here I rotate. So when it, actually yes, here what you have to, already we have marked 50 mm, is it? So by looking, if you look from top, the plan of the true length, okay, looks, is it? That is parallel to horizontal plane. So that should be in looking in elevation, is it? So that is the actual AB is represent on plan. So how much that? 70 mm. That 70 mm only we have to chosen, is it? 70 mm. So we are not go for 50 mm. Is that 50 mm is while looking in elevation, that views. So whatever the true object you are placed, looking as a projected one. So the actual length is 70 mm. So for 70 mm we have to measure. So we have to measure by keeping here. So 70 mm we have to measure. So we have to measure 70 mm. Measure 70 mm. After measure 70 mm in campus, so placing over the point A. placing over the point A and intersect the projector drawn from the point 50 mm. Yeah, that is also we have to draw. Is it? I draw the dimensions 50 mm. So here we have to make intersections. So by using these perpendicular scales, so we have to extend this and also extend from outside to measure 50 mm. The same scale I have to move here. Away from and move this horizontal scale. Yeah, move the scales outside and mark irrigates on both sides. By using in software I am do this. So it's very difficult, but you have to understand the concept. Yeah, now this is for 50 mm. Mark 50 mm. We have to draw a projector. In that we have to construct the true object 70 mm long. 70 mm long. We have to move another scales, place over here and rotate and draw a line. Yeah, this is capital A. Yeah, this one is capital A. This is capital B. Yeah, I just erase because sometimes we have to follow capital B, that points capital B. So this is actually given in the problems. So actually it is given, the details are given here. So 70 mm long line is given to you. So for that you have to draw a, yeah, for this you have to draw a extension line. So yeah, you have to draw a, I roughly do it by using scale only. So you have to do this. Here it's for time consumption I am doing this. So 70 mm long, that is capital A, capital B of here 70 mm, above 70 mm. So this is actually given in this problem. So what they are asking now, draw the projections. Actually it is not a projection. So it is a projection of plan and projection of elevation. So if you consider any one of parallel to plane and project the other one, then it gives like this. That is the concept of given in this problem. But draw the projection and determine the inclination with HP and VP. That is projection, not true inclinations. Here they are not asking true inclinations. So how to construct the projection? Already I stated projection is nothing but the endpoints lies in the same projector. But try to look at in this problem the end A dash and A, that is elevation view and plan view of one point is in the same projector. So we are construct, that is there, that is we are make it as. What about the other point? What about point B? So point B of elevation view B dash, the point B of plan view of small b. So where? So reverse, because by the projection we are determine the true length, but here true length is given and their views are given. By individual we are constructed and now we are make it in single projections. So how it is possible? Here now. So reverse principle I already stated. So what is the meaning of rotating line methods? So according to rotating line method only we are doing here. So we have to kept, that is we have to draw a, yeah, for such a case I change the color, but it not happen in your drawing sheet. You have to use only H pencil. So H pencil, 2H pencil. 2H pencil is basics, H pencil is final work, only tracing. okay. But for understanding of principle, I just change the colors, green color, okay. I just change the colors to draw the loci line. You know what about the loci? Loci is nothing but parallel to the planes, that is, it not change the positions. So I have to draw the locus line from A dash, so I just draw the locus line. Yeah, similarly from A, in similar to the other point, is it similar to other point? I already state that, that's why I am telling, because the true point or any viewpoints that lies in same locus line, that is loci line, okay. If you trace anywhere by looking the elevation views or plan views, but in the projection the plan and the elevation should be in present same projector, that is in projection. But in parallel, if you looking in the above xy or below xy, if you look about A dash anywhere, that should be lies in the same locus line, it not change, that height is not change anywhere, that is given in the condition. So that since we are draw a locus line, that means if true point is there. So what about elevation views that lies in the same distance of true points? So here there is a true point, is it true point of B here, in that same locus line the B dashes lies, that is the concept. In the same locus line the B dash is lying. Similarly in bottom, in this the same locus line, in this line only, so small b is appear, that is the concept. So locus line we drawn, is it, but we are kept one point as constant, it not change, so that is A, so that itself no problem. Then so what about other rotating line method? What is the concept? If you keep A dash as constant, rotate A dash and that, is it A dash and that, but what is the concept? Projection A dash B dash as radius, make an arc by keeping center A dash up to the locus line of A dash, is it, to determine the true length. So A dash B dash as radius, draw it and up to the locus line of A dash, then extend that radius as a projector, that is projectors that intersect the locus line of small b, so that will give true length, is it, that is the concept. Yeah, here reverse, what is the reverse? From the true line, from the true point, draw a projector up to the locus line of A, from elevation, is it from elevation? You know what about the capital, I just change the color and mark it here, it is capital B, okay. So it extended, okay, that extend. So what about, I just change the color and show to you this particular points, up to this particular point you have to draw a projector from the elevation, because the point A is constant, is it, so up to that line you have to draw a projector, from that you have to measure now that distance and small a as radius, so then make an arc to intersect the locus line from capital B of plan view. So now take campus, this campus needle point is kept at small a and measure up to this distance, up to the distance measure as a radius. So now we have to keep it, is it, because capital B, this is locus point. So what we have to determine, yeah, this point, is it locus point of which one? B dash there, but locus point of B, yeah, from this only we have to take. So small b, locus point of B, so LB. So now small a and LB, locus point of B as a radius, So, make an arc to intersect the locus line from plan view of capital B. That is, yeah, we have to rotate this, we have to rotate to intersect. Okay, I just rotate from here onwards. Yeah, that's better for understanding. From here, I just change the colors into black. Yeah, here. Yeah, try to look at this. Yeah, this point is small b, that point is small b. I understand about this. This is small b because reverse principle. Yeah, from a b, that is small b as radius, make an arc to intersect the locus line of a. So, from that point draw a projector, that projector intersect the locus line of b dash, that points give the true point of object. That is the concept, is it? In reverse we are determined now, because we are knowing about true point capital B. From the draw a projector up to the locus line of length, that is small b, then draw an arc, find out small b. So, this is the projection. Okay. So, we have to determine, is it? Yeah. In similar case, a reverse principle, is it? What about in other views? Plan view. From the plan view, what? Yeah, there is a capital point B. From that draw a projector up to a dash locus line, I just change the colors now, up to this point. So, this is L B dash up to that locus line, okay. L B dash, yeah, in this point. So, now measure this distance, that is 50 mm, is it? Yeah, that is why I am telling now 50 mm. So, now take this campus to here, up to this a dash as here and rotate. Okay. Roughly we have to do it, is it? Because roughly we have to do it, otherwise it not gets. Roughly we have to do it this. Yeah, otherwise it is not perfect. This radius, okay, this radius. So, we have to go for scale. Yeah, this is to be arc. So, we have to draw arc, that is by keeping a dash, because it not accept, that is why I just to move on some other distance. This distance. Move away. So, that, yeah, further we have to move, is it? Yeah, here. So, we have to take compass and place it over here and bring it this. So, make an arc up to this. Placing outside. So, that point, yeah, this point is now B dash, that point represent as B dash. So, now draw a perpendicular line passing through that. Yeah, placing the scales, try to see, it is same line, because already I stated So, any views say B dash that lies in the same projector of plan view. So, it not have any separate. So, that is the concept. So, now we have to draw a projector. Projector, this is a projector. It not trace. The trace is nothing but A B, capital B, A dash, B dash, capital A, capital B. So, this is the concept in these problems. So, after completion, so we have to construct this by using H pencil, draw a projection by take scales, then pencils. I just change over the color because by using H pencil, so you have to trace. By using that, I just change the colors. So, now move the scales and keep it as A and up to this. So, now draw a line. So, this is projection. In similar case, from A dash, B dash. So, draw a line. So, this is A dash, B dash. Also, the true point is it capital A, capital B. That is also you have to trace by H pencil. That is also we have to trace by H pencil. So, that is final touch up. So, this is the concept to develop and solve this kind of problems. Already I stated is it how these problems are solved, because sorry, here in this problem the plan and elevation length of line AB 70 mm long, 60 mm and 50 mm is it. Yeah, here we have to look because the 70 mm long is look from top. So, if you look from top means what? Yeah, if you take this straight line from top, this is the true length is observed from elevation, is it? So, if you look from top 60 mm, so you have to measure the distance between 60 mm and construct the true length in above. So, that is did here. Okay. First you have to mark 60 mm, draw a projector. In the projector only you have to mark a true length capital A, capital B first. Then only comes to the other views. Similarly, you have to mark 50 mm. So, in that 50 mm you have to represent the true length 70 AB. So, afterwards the reverse principle, okay, because you have to how to determine the true length is it the same fashion, have to determine the projection reverse from the capital B, draw a projector up to the lossy line of A. So, from that you have to measure a radius. So, A and LB, A and LB as radius make an arc to intersect the locus line capital B that represent in plan view. That intersect point gives small b, that A and B gives a plan views. So, in similar case from capital B of plan view draw a projector that intersect the A dash lossy line, that point L sub LB dash. So, then measure A dash and LB dash as radius, make an arc to intersect the lossy line from the capital B of elevation. Okay. So, that point is determined as B dash. So, if you draw a line from B dash, it passing through small b, or if you draw a projector from small b, it passing through B dash. So, that is projection. So, what about the finally the statements? The draw the projection is over and determine the inclination with HP and VP. Determine the inclinations with HP and VP. Yeah, now it comes to here how to determine. So, we have to take protractor and keeping in this point and rotate. So, this is above HP means above XYZ, yeah, from this. So, what about the inclination, how much it makes angle? So, how to do it? I just move the other scales away from here, and the scales, by using the scales, yeah, you have to draw a guideline approximately 5 to 6 mm, approximately 5 to 6 mm. Approximately 5 to 6 mm, draw a guideline. So, only one question or two question 2 with respect to HP and VP, therefore, 2 guidelines we have to draw. So, I think it is very lesser, is it? Yeah. So, here we have to print, is it, the inclination of HP, the inclination of A dash B dash, that is HP means A dash B dash only. So, here, so we have to write the inclination of line A dash B dash is how much A dash B dash with respect to HP, that is with respect to HP around 42 degree, but exactly here, yeah, here measured. So, A dash B dash it to be around, so we have to place, yeah, we have to reduce these scales. So, then we have to understand. Placing this and reduce. Yeah, try to look at 46 degree. Yeah, try to look at this 46 degree. By measuring this, we have to print. So, 46 degree. So, we have to print below the problem, each and every problem, that answer for that particular question you have to be print below this problem. So, similarly, the next guideline, the inclination of line AB is, but here in 46 degree with respect to 46 degree to HP. So, similarly in bottom, so this you have to place here and rotate. And find out. So, how much is this? 10, 20, 30, 40, 50, around 55 degree. So, is around 55 degree. So, 55 degree to vertical plane. So, like that we have to print, yeah, in this sense only we have to print, okay, print the answers below these problems. So, this is yeah, this is, so by this way only we have to complete the projections and the details for particular problems. So, now we move on to next problems. Yeah, now we move on to next problems. Yeah, here I just rub all and repeat again, okay, just I go for rubbing all. Rubbing all the cases. So, now problem number 4. Problem number 4. Now, we are going to look about problem number 4. So what I said, while you start any problems, immediately we go for draw a reference line, xy line. So therefore we have to draw a reference line. Draw a reference line. Now move on to problem number 4. So one end of a line 60 mm long is in HP. So try to understand. So now one end of, try to see here, one end of line 60 mm long is in HP. In HP means what? On XY line, 20 mm in front of VP. 20 mm in front of VP. So it is inclined at 35 degree to HP. So what's given here? Okay, first we have to read out all, then we come for determination. Okay, its elevation measures 40 mm. Its elevation measures 40 mm. Draw the projections and find the true inclination with VP. Okay, what's the sense here they are given? One point is in HP and in front of VP is here. Yeah, now we are take one point. So now we represent one point here, that is A dash. Yeah, we have to make it as A dash. So this is A dash, A dash. Next we have to take a perpendicular scale in minute drafter, placing over and mark 20 mm in front of, that is below XY. 20 mm in front of, 20 mm in front of. So draw a projector, draw a projector. Draw a projector. So draw a projector. Yeah, here because what we are setting, because with respect to VP, that is plan. So in front of VP means below XY. So mark 20 mm and represent small a. But what about the problems here? 60 mm long, that is true, is in HP. Okay. So 20 mm in front of VP, that is also marked. It is inclined at 35 degree. So to HP, HP means above. So now we have to mark, take protractor, that is pro-circular protractor we have to take. So then we have to placing over here the center points to A dash. Placing here, a slight variation is there. Yeah, placing here. So how much angle it inclined? 35 degree. 35 degree. 35. So 35 degree is inclined. Is it 35 degree? So to HP. So we have to mark 35 degree. Its elevation measures 40 mm. That's also concept. And come over here, 35 degree we have to mark. So 10, 20, 30, 35 degree is here. So by using this, we have to draw a line. Is it? So draw that line by keeping this scale, because try to use minute drafter. Yeah, here there is no provision for that. That's why I am using ruler. So draw a line. Okay. So 30 degree line I drawn here. Yeah, this is 30 degree. So what to do? Elevation measure 40 mm, because 35 degree it's given. Elevation measures 40 mm. That means you have to measure 40 mm in scales, or you have to take scales over this 30 degree line. and measure 40 mm, measures 40 mm, try to observe 40 mm, 4 centimeter, observe in the scale, mark over here. From that draw a projector, already I said, is it? So the points, one points, either elevation, true point or plan views, all points lies in same projector, same projectors, but we cannot say the capital, the true point lies in, but sometimes the true points and the other views lies in the locus line, that is loci lines. So now take scales, draw a projectors. So draw a projectors from this. Draw this, draw a projector to that points, because that measurement line gives these measurements. Here we have to draw a up to 4 mm, you have to draw a parallel line, then perpendicular to that I roughly drawn because it takes some time, is it? That is extension line. I just erase the middle part, then I go for arrow gates. Similarly here, then it's measure 40 mm, is it 40 mm. So next steps are draw a projector from that B dash, this is B dash, draw a that is give a denotation lettering B dash, then draw a projectors from that point. So what about in these questions? Its elevation measures 40 mm, we have completed, then 20 mm in front of 35 degree, it's okay. But what about the other parameter? One end of line, one end of a line, 60 mm long is in HP, 60 mm long is in HP, 20 mm in front of VP. It is inclined at 35 degree to HP. Its elevation measures 40 mm. Draw the projections and find the true inclination. With the VP. So what about true inclination with VP? So true inclination with VP is looking from where? Above. So that is the concept, is it? So by looking above only it observe. So that is here. So how to observe? A is given, is it? You have to fix that point. So from that point measure how much true length? 60 mm. So measure 60 mm, make an arc to intersect this. So now it take the scales. So placing over here and measure 60 mm. After measure 60 mm, so move this. Could you understand? Here placing on A. So make an arc to intersect that. So I just extend this line also. So I just move the scale and extend. So this point is give capital B, this is capital A. So now draw a projector. Already I draw a projector, is it? Then why need draw a locus line? So for that I just change the color as green color, is it? But you have to use 2H pencil, okay? So now placing this on capital B, so draw a locus line. Then placing on capital A or small a and draw a locus line. Similarly, because there is no need to draw a locus line on A dash, because that lies in where xy itself, that is reference line itself. So, no need to draw a locus line. Then we go for to draw a locus line from B dash, from B dash. So, draw a locus line. So, what about the concept here? Now we are obtained. The main objective is, could you understand the main objective? How to determine the true object in that? How to determine? Because the concept is it the true is it? So, the true object is observed, is it here? The true length is given. So, true length is given means you have to measure 60 mm and make an arc on the locus line of B dash. It is very simple, is it? From that you have to draw here. That is the concept. Could you understand? But the projectors, but this is lies in, I think actually here it not represent, is it? The true object we are intersect from here. So, how to represents? One more. But here how to obtain this B, capital B or this? So, reverse principle, is it? I already said, but if you are draw the projector, it is no problem. But true length, the true object we already known, but I am not need to extend. Okay, sorry to say here, this is not a true B, true object, but true object you have to draw an arc, is it? That is the true. So, this is true to construct, that is no problem. Okay, just this arc up to this. This is the concept, is it? But actually how to determine capital B? So, already I said, what I said, how to determine the true length from A dash B dash, from this is just noting on here. So, A dash B dash as radius, is it? So, measure A dash B dash as radius, make an arc. So, what about A dash B dash? 40 mm. That 40 mm I want to measure here by using scale itself. I measure, because this campus not adaptable for small scale, that is why it is very tedious. So, measure 40 mm here. So, make an arc. So, measure 40 mm as radius, A dash as center, A dash B dash as radius, make an arc up to this. So, this is locus line of A dash point. So, from that draw a projector, from the draw a projector, from the draw a projector, from the draw a projector. But actually this is not a locus line, this is not a locus line. Actually this is not a locus line. Okay. So, draw a projector, that projector intersect the radial line of the true length 60 mm. So, that we have to mark it as capital B, this point. So, now draw a locus line from this point only. Now, draw a locus line from this point. Now draw the locus line from this point only. That's why I am telling, because how to determine the true length in the similar concept. So therefore we have to trace A dash B dash. So from the draw a projector, so that will intersect the radial line of, so capital A capital B, that have the locus line. So this locus line is intersect by the projector drawn from A dash B dash, that is called small a. This is called small a. That is called small a. So now using, so what is the questions? Draw the projection. So already elevation is there, plan only to determine. Now we are found out plan. So by using scale, so construct a projection and true length. So only true length is one is enough, the other true length not needed. Okay, that is with respect to VP only they are asking, that is enough in this problem. So now shifting this scale and draw this, by that by using H pencil trace. So I just use here red color. So trace A dash, so red color, trace A dash, B dash as projection, then similarly A and B. So A and B, and in similar true object. So that is also true object. So these two details. So that is the logics, is it? So what about the problems? What about the problem here? It is inclined 35 degrees. It's okay, already finished. Draw the projection. Projection is completed. Find the true inclination with VP, with respect to VP. So where we are observed that VP for true above, that is plan view. So we are move on to the plan view. So draw the guideline below. Draw the guideline. So now print. Yeah, now placing this protractor, is it? Now placing this protractor here. And find out. So what about the inclination? Inclination of VP means true inclinations. The true inclination, is it? That's we have to type the true inclination, or small a small b, that is they are asking apparent inclination. So we have to write it. The inclination of line small a small b is, so how much it is? So 10 20 30 40 50, around 53. So 53 degree to VP. So we have to print, so otherwise it not fulfill the problems. So that is the condition here. So by this this problem is over. So problem number 4 we are completed. Yeah, we are completed. Yeah, final touch on this projection of straight lines by completing the 5th problems. Yeah, this is enough for learning. Much is not required, but further in advance if you go for, we are giving another session also. Okay, so that's, yeah. Now move on to the next one, is it? So now move on to the problem number 5. So what about the problem number 5? The plan of a line AB is 80 mm long. So 80 mm long is a plan of line 80 mm and makes 30 degree with XY. Its elevation makes 45 degree with XY and the line intersect XY at A. Find its true length, because here true length is not given. So, and inclination to HP and VP. So, they are not asking any two true, but already they are given inclination with respect to apparent, true inclination is asking. So, now we go for construction, is it? So, what about the initial? Take scale. Yeah, first we go for problem number. So, draw a circle 6 mm. Yeah, here I roughly draw by using mini drafter or any 6 mm, a small scale, okay, radius. Draw a small circle. So, in that only you have to represent problem number. So, this is 5. Then change the colors and line, take scale and draw a XY line, draw a XY line and this. So, one, that is what they are asking here, the plan of AB is 8 mm long, makes 30 degree with XY, its elevation makes 45 degree with XY. The line intersects XY at A. So, we have to keep it at one point here, that is both, that is A dash is here, A is here, capital A is here. Everything is in that on HP, that is intersect. So, that is trace. So, then what here it stated, so 80 mm long plan 80 mm long, so makes 30 degree with XY. So, now we go for take protractor and placing over here. So, measure 30 mm, 10, 20, 30. So, 10, 20, 30, measure 30 mm. So, what about the other one? Its elevation, makes 45 degree, plan 80 mm long. So, line AB is 80 mm long, makes 30 degree with XY, its elevation makes 40 degree. So, here 80 mm long is it, whether it is true length or apparent, because question itself it's very clear, it's not true length, because it's here they are asking true length. So, 80 mm is not a true length. Okay. So, now 45 mm. So, measure 45 mm above XY, because HP is it. So, that is why. So, rotate. So, rotate in the same point. So, same point, measure how much? 45 degree. So, measure 45. Measure 45. So, after measuring, this roll is completed, then replaced or away from the working area. So, now, yeah, there are 2 points, is it? From this point you have to draw a line. So, we have to move the scale from this and rotate up to this 30 degree and draw a line. Yeah, similarly, we have to rotate up to 45 degree, draw a line. So, this measurements gives 45 degree. Yeah, this gives 30 degree. So, that is given in the problem, but plan is given 80 mm long. So, measure, take the scales, placing over here and rotate, mark 80 mm, 80 mm in this. So, plan is given, is it? So, what is the meaning of this plan? So, B, small b is given. So, therefore, from this draw a projector, from this draw a projector, from this draw a projector. That projector intersect elevation at incline 45 degree. So, already I said, if you found one view, the other views lies in the same projector. Therefore, we are already found B. So other views of B dash lies in here. So we have to represent this point as B dash, B dash. So now it's completed. Is it projection is over? Projection is over. So how to determine the true length? How to determine the true length? It's very simple, is it? So what is the concept? Draw a locus line. So one locus line already is there in XY line, that is A. So capital A, small a dash, small a, that lies in same XY. So only we have to draw, is it? So we have to draw. I just change the colors, green, and draw the locus line from small b. So similarly from small b dash. So locus line, that is losing. So what about concept? Measure a dash b dash as radius. Measure, now take this campus, keep it as a dash and rotate from here. Measure a dash b dash as radius. So make an arc, just moment, because here I want to select this make an arc up to XY line, because I stated, is it the locus line is lies in the same. So up to that you have to draw a radial line. Okay, up to that we have to draw a radial line. From that radial line, draw a perpendicular line, that is projector. From that draw a projector. From that draw a projector that intersect the locus line. That intersect the locus line here, that is capital B, that is capital B. We have to measure. So we have to measure and drawn. So that's why. So we have to measure. What about these measurements? Finally I tell you. So how to? Then similarly in reverse principle of here, the same distance it not change. The campus I am take and rotate for here in this and measure small a, small b as radius. So small a, small b as radius, make an arc up to the locus line of the constant point a dash and capital A. So then draw a projector from this scale. So move away from here. This point gives capital B. So that is a true length. So now we have to check. So what about the true length? Here we have to observe, is it? So now we are move this scale over here, and perpendicular scale, is it? We have to draw a perpendicular. Just I have to draw a line, dimension line. Thereafter I have to erase, no problem. Similarly I place over here and draw a parallel line to this true object also I have to draw. Actually I did it wrong here, because I have to draw for true inclination, is it a true length. So for that I have to set this parallel and move from here and draw a line and set over here. Then I have to take another scale, is it this scale perpendicular to this. yeah, perpendicular. So perpendicular to this I have to set, so here, so this is nothing but extension line, then move the scale to here. So extension line, yeah, remaining things we have to rub it, is it, that is no problem. So what about the measurements it shows? So what measurements it shows? Yeah, around 10.4, that is 104 mm true length, 104 mm true length. Yeah, I just erased in middle part, and this portions, extended portions I just remove. Then I have to print here, is it, so 104 mm. Okay, then draw a arrowheads, draw arrowheads in this, in similar fashion, is it. So there also we have to move the scales to their and true. Yeah, similar in this we have to set this scale perpendicular to that, the scale perpendicular to this. So perpendicular to this, yeah, draw a extension line, draw a extension line. So we have to move away from here, because this is enough, is it, already I completed, is it. Yeah, we have to draw a tracing line. Okay, I just erased the extension portions. Yeah, so here it's in this area, it's then erase middle portion and print the measurement 104. So similar, yeah, that is the questions. So what about find its true length? True length is 104 mm. So and inclination to HP and VP. Yeah, let's read to find. Yeah, here we have to trace, is it, a projection as well as this. So for that, so change the colors, that is it determine, is it, it determine tracing, capital A, capital B, capital A, capital B. So that is for true length. So this is projection. That is A dash, B dash. In similar fashions, we have to do it for this capital A, capital B on elevations. For projection also, we have to trace. Yeah, in similar fashion, this also we have to move away from this and mark it over here, is it. So we have to print, is it, already we found. What about the true length 104, that's also we have to print below, by using pencils, is it. So draw a guideline approximately 6 mm. So I am doing 3. So one for a true length, so another for inclinations, yeah, here, then take protractor and placing over here and observe. So, what about the inclination of capital A, capital B, is it? So, first we have to find, so the true length of line capital A, capital B is 104 mm, and the inclination, the true inclination of line AB is, so how much is there, because in the rotating line, is it, in the rotating line we are found here, is it, but in the trapezium, in trapezium method only it's similar, is it, what about A and B is represent below. So, AB represent below means, so whatever you get it below, that should be theta. So, that is with respect to horizontal plane. So, whatever you have to mark over that, that is inclination, but here as it is, so above HP means above HP, theta is there. So, therefore, is, so around 40 degree, so 40 degree HP. So, similarly you have to print the true inclinations, the true inclination of line AB is, we have to find. So, we have to find, so what about this one? So, around 20 mm, 22, around 22 degree VP. So, this is the concept actually followed in projection of straight lines. So, you have to print everything and also mark the dimensions. So, dimension also very important to legible of your draft or graphics, that is drawing. So, that is neatness. Okay. So, you have to clearly develop each and everything, and neatness is very, very important. So, these are the concept how to develop and how to determine the various problems. So, as stated in this, if it is given in this fashion, how to generate projections, how to determine the true length and how to determine the true inclination of line with respect to HP and BP. So, these are the cases. So, these particular problems are enough to construct projection and determine the true length and the true inclination and so on. Yeah. So, how we are represent the true inclination, because capital A, capital B, is it. So, capital A I just mentioned in red color. So, what about this one? So, why I am say this is theta, how this is looking theta, because I projected, is it. So, where I projected, it is from AB, from AB I determined this. So, AB means what, AB. So, AB I have to put it parallel. So, try to imagine AB. So, try to see here in this, try to see rotating line method, that is why I am telling. Yeah, here by looking above, A and B, is it. So, A and B is there, but while you rotate, what happens? So, it is a rotating means, yeah, from here it to be rotate up to that parallel, it rotate, that is rotate means this horizontal plane rotates up to the locus line, the horizontal line is rotate. Okay. So, because capital A, capital B is to be find out, then draw a projector, that is the concept, is it. Yeah, try to see in this trapezium, yeah, if you find the distance of A and capital A, that is the distance of A, small a and small a dash, that distance between. So, from the elevation, perpendicular distance you obtain and placing over and find out. So, from that, so whatever you have to mark it on plan view, in the plan view if you mark. So, what about this inclination, true inclination with respect to HP. So, where it look below xy, below xy it looking marking on A and B, because you have to keep in mind. So, what type of method we are applied, because if you are applying the trapezium methods, so you have to observe the distance from A dash, perpendicular distance. So, that is from the, so from xy to A dash you measure and mark it over small a, that perpendicular distance, that gives capital A. Similarly, from the perpendicular distance from xy to B dash, so measure the perpendicular line of small b, so that gives capital A, capital B. So, actually what inclination? Theta. Yeah, that's why I am showing in this. But what about rotating line method? In the rotating line method, we are shifting, is it from B, we have to make it parallel. If you make it parallel, what about the inclination you obtain on plan? If you make it parallel, this parallel, so it is parallel means, so it is inclined to Vp, it not inclined to theta. So, that is by rotating line method. So, with respect to xy, above is inclination theta, below is pi, that is the concept. That is the concept. Yeah, that is why, because theta is above, not with respect to A and B, theta is with respect to A dash B dash, in that only we are up here theta. So, beta is up here below, that is theta, and pi is it alpha and beta, that is for with respect to apparent. So, this is theta and pi. Okay. So, this is true inclinations. So, it is very clear where it to be observed, what method we are using here. Then what about whether it is above xy or below xy, the true inclinations with respect to HP and VP, that is the concept. So, by this we are completed. I judge, okay, you understood the concept. If not, again you repeat the session and go through, then it is very clear how to generate particular projections and determine the true length and the true inclinations, so on. So, with this I conclude. So, thank you dear viewers and friends, see you.